working as project assistant on the Naharkas project, Anand Agricultural University, Anand. I welcome you all for the second day of the lecture series on agricultural market intelligence and eNAM. Now, I would like to invite our former professor and head of the department, Agricultural Economics, IRI, New Delhi, Dr. Kumar sir, for the today's session. The topic includes demand and supply analysis.
So we can already or to look at that. Should we worry already? So this is anyway, let's start with something. Okay, demand supply. Yeah, this is the old one. Just go here. Okay, demand supply. Okay. लाने वाला है कोई बात नहीं सर मैं लेके आता हूँ नहीं सर उन्होंने चेंज किया कोई बात नहीं मैं इसको ग्रोथ और चीज सिखा देता हूँ नहीं सर उनको नहीं सर थोड़ा चेंज किया सर ओके so what is demand okay you define demand it is a function of price of substitutes, price of complementary goods, income. Okay, let's say income. This is your demand. The demand influenced by on price, price of substitute, price of complementary goods, and income. Very well. So what is this? Through the price, the income is the shifter, population may be shifter, and so. So I want, let's say, you just feel that this is a regression model. Okay, you just try to fit demand, consumption per capita is a function of price of substitutes, complementary goods, and income. But most important part is any function you write, you must convert into the growth model. Then it has a very high practicability for policy analysis. So you differentiate, make a total differential of this. What is total differential? You take a partial differential, EP, dP. Then plus total differential with respect to price of substitutes, DPS. Similarly, you take another variables, let's say differentiation, price of complementary goods, and DPC. Then you say DP is equal to DI, then changing I. Correct? Can you write this? Now what you do, you divide by D everywhere. No problem? No problem. You divide by P here, multiply by P. You divide by PS here, multiply by PS. Divide by PC, multiply by PC. Divide by I, multiply by I. What is this? This is the growth. You are making changes in demand with respect to total demand. So this is the degrowth. Growth means growth. What is this? What is the formula? What is the formula for price elasticity of demand? Change in demand divided by change in price. Delta D, delta P, P and D. So this is the elasticity. So you're writing price elasticity of demand and then P growth. Then you are getting price elasticity of substitutes, D growth and PS growth. You are also getting the price elasticity of complementary goods, D, PC growth. Then you are getting the income elasticity of demand, I growth. Right? So it is so simple. So what you can do? You have the time series data on prices. You work out the growth of price. Let's say this is wheat consumption. You can say price growth. What is the growth of price of wheat? What is the growth of rice? Substitute. What is the growth of, let's say, milk, of milk, right? And income growth. So for simplicity, you just say, let's say there is no effect of other factors, price of demand, E growth plus income elasticity of demand, I growth. You say this is the price effect, this is the income effect. So any place, any literature, you can find the elasticities. From the time series data, you compute the growth of price, the growth of income, then GDP growth, 10%. Let's say example, the price elasticity of demand is minus 0.5. Income elasticity of demand, let's say 1 for simplicity. And the P growth, price is increasing at the rate of 2.5%, let's say. And income growth, GDP growth per capita is 5%, let's say. So I'd like to know what will be the demand. The demand growth is equal to the elasticity minus 0.5 multiply P growth. How much P growth? 2.5 divided by 100. Then plus income elasticity 1 and income growth 5 by 100. So just you say, then you work out some numbers. Okay. Then you can work out this number. So this is the demand growth. Now you want to project. You want to project the supply demand. Et is equal to consumption is here 1 plus the growth, just like compounding compounding interest formula. Okay. So you can project the demand if you know the growth, right? So what is the main point here? If you think this is my dependent variable, this is my exponential variable, you write in the functional form. Either it is a demand model, it is a supply model, it is any regression model. So simplicity. Clear? Right? So this is the most important part in our policy analysis. As soon as you think about dependent variable and independent variable, your mind will start working like a regression equation. You start collecting data, you start thinking that I must regress and get beta coefficients. But that is not important. You must convert that model into the growth. And once you convert to growth, everything converts into elasticities. Then think how to get those elasticities. And rest part is become simple. So this way you can project the demand, basic consumption, and so on, right? That is why in the textbooks it might be given like this: your dt is equal to the 1 plus income elasticity of demand I growth. I think this is the thing given in the textbooks. Your elasticity of income growth, and then you get the consumption, and then you multiply the per capita consumption multiplied by population, you get the total demand. This way we complete. So now, once I was talking about the models, okay, so this part is important. Which comes, you can use in your third board. No. So I shown one slide yesterday where I shown a supply model, demand model, and trade model. I say this is a producer cost system, this is a consumer cost system, this is a trade model. Remember that slide. And then I wrote a number of equations how you can do it. Let's say I just said all the dependent variables. You can write any dependent variable. Let's say I am writing a supply. Supply is a function of what? Product price, input price, fixed factors, and technology. Okay. Your demand is also a function of product price, price of substitute, price of complementary goods, fixed factors, and technology. That also comes. Or income, let's say. I just put income. Okay. Then you say supply is equal to demand, and then you compute the price. And I say your price is a function of small p, j, t, and I. So that way we write all kind of model, your package model, demand model, supply model, everything. Remember, you don't know what is demand, what is supply. You want to write a regression model. What we say? Y is a function of your x1, x2, x. Now by this you can define anything. X1 may be price. So if I ask you, you write a growth model for this. What will be the growth model? Why growth? Very simplicity. No need of driving. X1 by Y elasticity or X1 group. Similarly, you keep writing your X and elasticity, Y and X and growth, right? So only you have to think about this. What is this? Whether it is supply elasticity, the demand elasticity, the income elasticity, the climate elasticity, the KP elasticity, what are the elasticities? Then only your mind must be which model I should use so that I can get these numbers very good. If you are not able to compute yourself, search the literature, find the number, and still you can do the policy analysis. 99% cases, those work in the policy, they don't compute elasticity. They take the reliable number of elasticity from the published literature and then apply to the formula and work out on it. Right? So similarly, your cost model. What is the cost? You are the cost is your summation Pi Xi. This is the cost of cultivation. Pi is the price of highest input, and Xi is the production, is the input. This is cost, right? And your demand Xi, it is a function of demand for inputs. Your P, small p, get shifters and technology. So once you substitute over there, your C is also become a function of these factors. And if you want to write a growth model, cost of production, you want to see what will be the growth in cost of cost, or you have supply model, let's say. Supply is also function of your P, small p, Z and T. So what is the cost per unit of what is the cost per unit of output? You say C growth minus K growth. So this also, this is the cost of production. You want to fix the price. How to fix the price? Your P is equal to your P0 1 plus cost, increase in cost per unit of output. So this way we project the cost. This is T minus 1. If last year price was T minus 1 and the growth in the cost of production is 5%, my price should be fixed like this. So just like the price summation, fix the price based on cost of cultivation, cost per unit of output increase. So now this thing we can estimate through the output model, through the factor demand, we can estimate the cost elasticity. Those formulas, if you drive, they come quite big. But if you read our papers on that line, sugarcane paper, the paper, you can write very easily the formulas. You may not be able to drive. One can attempt to drive also. A lot of differential calculus come, but one can do it. That's what this is. So, for any policy analysis, you require to understand that any regression equation can be converted with the growth model. If you convert with the growth model, then that is the equation will help you to answer your policy questions. I may say, if I increase my supply by 5%, what will be growth in income? If I reduce the price of inputs by 5%, what will be its effect on supply, the demand for inputs? What will be its implication on cost of cultivation? Then once cost of cultivation comes, then you can say how much credit required. because cost of cultivation increased by 10%. How much more money I need to purchase the inputs? So that comes under the demand for carry and so. Then here you work out if the prices goes up, what will be the effect on a supply and how? And if I want to increase by P, reduce subsidy by 10%, how much I should increase T? So it remains constant. Just like an isoprene we have, Q is a function of the P and E. That's it. This is isoprene. I can draw. This is my Q, this is my P, T, and this is my P. I say if I reduce the subsidy, right? If I increase the price, right? I can reduce same level of output, I can produce with lesser technology. If I cut the prices from here to here, I'll just increase this much TFP. So that way we think about that. So here, the idea was that this is most important one. You write any integration equation, you can write in the growth model. And to write in the growth model, the first estimated variable elasticity of first variable with respect to the this elasticity and then growth. So this, once you remember, only this is step in mind without thinking whether you are writing a demand model or supply model. Right? And any work you do, you always define dependent and independent variable in each statistics. Right? Here also in the policy analysis, either you do the demand analysis, you do the price analysis, you do the supply analysis, you do the factor demand analysis, factor supply analysis, active model, impact of drought, impact of subsidies. Everywhere you find dependent variable and expected variable, and then write in growth form, convert to the elasticity, and try to think how to get those elasticities. That is the most important. Right? This is the whole scope of the policy analysis. Okay.
Sir, technology make this one small.
Yeah.
How we address the technology? Because technology shortman is considered zero or constant. Sir, normally in production function analysis or price analysis, if we write technology T, if we don't write technology, argument is you have mentioned a T, technology. My question is, sir, technology is constant during one specific period. So,
Technology is very constant.
yes, sir.
Right. But it is a dynamic. The time period will get changed. First you have PC without hard disk, then you have PC with hard disk, then you have XT, then you have another model 1, 2, 3, then Pentium 1, 2, 3, 4. So the time period you are changing the technology.
Sir, you are having your explanation for this ISO part. Okay, sir. But sir, technology normally we don't have a specific quantification, or we don't do quantification of technology.
No, that's why I said here.
Technology is clear. You are saying that's clear. Right.
No, everywhere is TFP is there. Each input has technology. That's why I explained in first one that each input associated with technology. That is why I said that your production function is a function of plus x1, xn. Then I say each input has two parts, x1 t1, x2 t2, and so. So you say your production it is a function of your physical inputs and technology. And that is why I also said the change in output is equal to elasticity of output x growth plus T elasticity on Q. degrowth. That is why I say your this section, that the TFP is equal to output growth minus input growth. That is why I just write that. That is why I say your TFP is equal to output index and divided by input index. That's the first question. Okay. We say everything is shifted by technology. Or what is shifters? Let's say you are 10 fertile factories, you increase 20, they are shifters. If your income is growing from 2% to 5%, it is shifter. Right? So that is a urbanization, literacy, all where will come. If you look at production function, quality of soil, irrigation, area, acreage will come under JAD. Right? So that is why each variable in economics, whatever the economics you talk, either you talk about market supply, demand, supply, input, all are the function of prices, these factors, and technology. Any example you take in economics, from beginning to end. Economics and only what I explained here. Total economics.
Sir, the simple analysis here is fixed sector. Simple analysis.
Shifter.
But fixed sector also like profit function. That is there one, there two. So there one is also a fixed sector. Like in case of dairy,
Everywhere.
sir.
Everywhere.
But you are explaining it is much more than that.
No,
Like
that always remain. It depends what is the definition of that. If you are doing the demand analysis, that is population. That is habit. That may be education. But that may be diversification.
not necessarily fixed. There is to be fixed.
No, fixed factor means you cannot change. You can assume from outside that my income is changing 5%, my income changing 7%. That sense they are fixed.
So by considering the dummy variables, we can.
Yeah, dummy variable, urbanization. You use dummy variable, which come under that. That is a factor. Can define the variables. E is a technology, right? We are making the food, right? How we are going to process so that the sufficient nutrients available to consumer. Then the key is the technology of food processing, maybe other things.
So this kind of definition you are explaining here, normally textbook we find that get one, get two, get three, fixed factor line.
That's why we say regression analysis. The dependent variable is a function of independent. Right? Then you define what is my dependent variable, what is my independent variable. Right? If we are talking about demand, you say my independent variable is the price on commodity, price of substitute, price of complementary goods, income, and so on. If you define supply, you say my independent variable is output price, input price, fixed factors, means irrigated area, and so on. It depends on. I say this is one definition. Under that definition, you can change everything. Just like they say, what is elasticity? Change in dependent variable divided by change in independent. The question comes, define me income elasticity. You say, change in consumption divided by change in income. Then someone asks in the interview, what is supply elasticity? Change in supply divided by change in price. Someone asks, what is income elasticity? Right? Change in income divided by change in price, change in technology. Right? So just remember one word, and then you say marginal the elasticity of substitution. If you know one definition, you can answer. Whole economics can be written in one page. You don't need more than one page to write all the courses in summary. During my PhD, I wrote only 2-3 pages, and and all the courses were there. Once there was an exam by David Hopper on macroeconomics. I was auditing that course because I had not done macro one. So that was macro 2 that I had. So David Hopper, who retired as a president of World Bank, so he asked that either audit or cabinet. You have to write the exam. That was his condition. Then I said, okay, sir, I will write. So once the exam is there, midterm exam, he said open book exam. And he set the paper running 10 pages. Each question running 2 pages. Right? And then he said, you cannot consult each other, but you can consult any library books and give me the paper that at 5 o'clock he gave paper.
See, and here,
When where do like here, but not. So our English was not that good, and reading 2-page questions is a problem. You know how to bear the problem is in the medium. Right. In that time, only the English was the just like
starting from system.
your time may be good, but
It's not a doing, but maybe sir, it is common. Yes.
no, not but there were no. Whenever we come to class, they make journalism. So that graduations is on medium of English. So we do. I wrote the all 5 questions in half page answer. Just one sheet half page answer. He gave me 99% marks. And then he said, you have been exempted from macro 1. No need of taking the macro 1. And he allowed me to get that course. In my say, okay, you can get that course and exempted 1. And so everything you can write in 1 page or 2 page, whatever the things you teach, read, answer. Only if you read, if you have the answer. Anyway, okay. Anyway, let's start formal presentation.
Nice, sir, this is the, actually, sir, this explanation is very, very important, sir. Even presentation we can have from you later on also, but the way you are explaining, even sir, we are using technology constant, but the way you explain this thing, we can use it this way that we have to define only explanative variable, independent, dependent.
Yes. And you can write any more. And if you know the differentiation, you can always convert into the model. That is why you must read sugarcane paper, okay?
Or
that transmission of cost inflation by myself and them. Okay, make you want.
will circulate, sir. It's all with us, sir.
Yeah,
The
that's
sugarcane model I told in the will circulate, particularly those who are doing work,
Yes.
they should concentrate.
But the sugarcane paper is not a basic paper. Basic paper is transmission of cost inflation by Jan and Co. That is the base of my entire research. Only one paper. That has changed our thinking of analyzing it. Anyway, so let's talk about a little bit about the demand analysis. Okay. So what are the approaches to estimate the demand? You have single equation approach. That is the estimation of engine function. This is the one which is taught in all the classes, graduation, undergraduation, and after. That conjunction is a function of per capita consumption is a function of income. You fit the equation and you get the income tax. Right? Then second approach is the demand system. What is the limitation of this engine? That if you predict the consumption, let's say you have 10 commodities and you spend your 100 rupees on 10 commodities, you say consumption of first commodity is a function of income, consumption of second commodity is a function of income, and so on. Once you predict it, the sum of expenditures will not be 100. Very different. Because you are not taking all the commodities together. You are keeping each commodity independent. Therefore, the angle function does not take care of, once you are analyzing rice, it does not care of wheat. If you are analyzing wheat, it does not care of rice. And it just cares little bit with the true price of potato. But if you sum up the expenditure of all the commodities, it may not verify your budget constraint. So we must have, once you have the utility function, what here? Your utility function, you have the budget constraint. And then where the tangent is there, the utility function and budget constraint, that becomes the optimal values of consumption to maximize the utility. Right? So same way, so we say we should not use the single equation model because it does not account, it does not satisfy our budget constraints. So we say, okay, use demand system. Take all the commodities together. If 10 commodity, you use 10 equations simultaneously, and then what? That is called demand system. In one system, you take all the commodities into account. So we started with demand system. Then first one was the linear expenditure system. So Radhakrishna started this work and other in India on Radhakrishna. So then we say, okay, we can go for AIDS model. The limitation of this model, they are widely used. We can estimate for group of commodities. We can estimate cereals. We can estimate the milk, vegetable, fruits, that. So aggregate. Let's say you have 5 all commodity in 5 groups. You can analyze by this method, linear exponential system and AIDS model. Then the part comes food characteristic demand system. Just like in the Anderson point, you might believe the Hessian matrix. If you know the Hessian matrix, if you know what is the utility, utility comes from energy, from variety, from money utility, and so on. And once you go to Hessian matrix or microeconomics, and using that Hessian matrix, by imposing the constraints on energy, on variety, on income, we can generate the elasticity. Output is 20 or factor demand, demand elasticity we can generate. Income elasticity and price elasticity, compensating and non-compensating. We can generate through the Hessian matrix and giving the Anderson point and other textbooks and so on. And that is the base of this food characteristic demand system. There is a one paper in the literature, which is the policy paper 98 at IRI. In that report, you find the food characteristic demand system, and based on that, we estimate the demand elasticities for all these subgroups of commodities. Right? And many times, still those elasticities are valid. If you don't have time, if you want to finish your thesis very quickly, you can choose the elasticity from that and use that. And you get a results as per the expectation of policymakers. Those elasticity are not going to change. Secondly, think that at the time pass, all the elasticity will be zero. Now, the elasticity may be high, but as we go with time, the assumption must be that with time period, the demand elasticity will decline. That is why the consumption of cereal is declining, consumption of high value commodities is increasing, but in Japan, all the elasticities are zero. If you estimate the demand for under the Japan environment, you find all the elasticities are zero. Whatever the per capita consumption multiplied with population, that will be a focus. But in India, we have quite variability of income, consumer, urbanization, dietary pattern, diversification is very, is to be stabilized. So only for serious they are stabilized. That is why for serious income elasticity almost is. For pulses, quite high. For milk, it's quite high. Vegetable, food, they are quite high. But with the time period, so whenever you make a projection, keep in mind that make assumption that elasticity will decline by 25% in the period of 2050, may decline further 25% by 2000, by the end of the century and so, and at some time. The paper which you wrote, Baroda Saab and myself, there we make this assumption that all the elasticity is come to be zero after a long time period. And that is why those numbers are still valid. So that's it. So we have the so food capitalist demand system give a very good elasticity. Yesterday I illustrated all the demand model had different elasticity, but only the food capitalist demand system having the elasticity where the calorie income elasticity almost zero, and that is why those elasticity guys only. The limitation of this model is it is a non-econometric model. With one observation, one can compute all the elasticities of income elasticity and price elasticity. You can compute, you can download your food consumption pattern, 1%. With one observation, you can compute your income elasticity and factor demand elasticity and compensating and non-compensating. Right? That algorithm is there. Nowadays, with new computers, that algorithm is not running. You have to go with the old. Anyway, so
Yes, sir, technically, sorry, sir. Technically, sir, how it is possible to estimate?
it is non-incremental.
Yes, but some assumptions are there, like you
That's why I say utility assumption. The marginal utility of money, variety, diversification, expenditure on non-food. These are the functions which govern the utility, and you have maximized the utility. Once you maximize the utility, you're building a asset matrix, and there you are making an assumption that because poor is there, utility of money is very high. If rich man is there, utility of money is low, and then calories. That for the rich man will fix some calories. For poor man will fix other calories. Under those assumptions, we are able to generate this. I think we have forgotten our ASEAN matrix, macroeconomics. Just read that. And from that, once we build up, we are able to get. The OD, he was a very scientist is working on, he's not doing economics research nowadays. He's doing the research on how to increase the zinc and phosphorus, other things, plant breeding and so. He's a breeder, global economics, right? And that's why he PhD was. And the paper actually can give that paper, original paper published in American Agricultural Development, and with 70 revisions, with 70 revisions, 70 times that paper was published. Yeah? That's why he PhD. And we work on that earlier up to 95. We estimated all kinds of errors from there. Yeah, that's why the base of policy paper demand supply 98 policy, and which with the matrix of all the elasticity of income supply. One can take that. Right? And if you make some of us do that. Now, the last one, the old letter, 3-stage demand system. Here we estimate the demand in 3 stages, which is a modified of Yates model. What is modification in Yates model? In this model, they use the quadratic income. That income goes up, the consumption start declining. It does not go up. That is why quadratic income has been introduced in the model. That is called quadratic Yates model. But we are estimating that model in stage 3. But we build the 2 more stages. That is what we say 3-stage demand system. So this is the one you are going to get a training on the estimation of demand using this model, 3-stage demand model. Somewhere it will be 2-stage demand model, somewhere it will be 3-stage demand model, depending how big this aggregation we are making. So that's it. So we have the angel functions. So you are aware about this. What is the angel functions? Must satisfy the budget constraint, right? Which is not there. We must represent the necessary goods, necessary goods that you are aware that if elasticity are negative, positive, how you classify them. They should have the variable income elasticity. So income elasticity is in the decline as the income goes up. Your income elasticity declines as the income goes up. This is the basic assumption of the function. And should reach a saturation point as the income increases. The consumption reach as a saturation point. As let's say in Japan, consumption per capita is not changing. Means elasticity zero. It is the assumption. So this you are already aware. Angel function, if it is a linear model, if it is a double log model, if it is a semi-log model, we look at the reciprocal model. Okay. I think here you don't need much explanation. Might be no need. Angel function.
Yes, sir. But yes, sir.
And then you compute the elasticity from and say. So mostly students are using double logarithm, so you get a direct elasticity to and semi-logarithm you get. Like similarly, you get the angel function, the linear form, which is the necessary goods, which is all luxury goods. Income elasticity ranging between 0 to 1, we say they are necessary goods. Why this is important? Once you are interpreting the elasticity, that time you require this knowledge. Whether goods necessary, goods is luxury, and so right. So similarly, double law function, if velocity is less than 1, we say normal goods. If velocity is negative, we say inferior goods. We say luxury goods if the velocity is elastic and so. And that's not a so so then things we know angle functions, so we are not spending much time. Just give a flavor while we are interpreting our elasticities. That knowledge is required. Whether goods is necessary or inferior, and so whether necessary or luxury. And so. Now, this is the model on which we are working, and we'll be working next 2 weeks on this model.
Yes.
Right. It is multi-stage budgeting framework. Why it is a multi-stage? You have income. You get your salaries. Once you get your fellowship or salaries, whatever you get, part of that you deposit in PPF or you make it FDs, and part of that you use for your expenditure. So we have total expenditure. We are talking about demand side only expenditure. Once you go expenditure, what you do? You just think how much I need for non-food items first. You never think about food items. You always think how much money I need for children education, how much money I require for transport, buying petrol, how much money I need for taking the house rent, right? First you take out that money in your pocket because that is fixed, you have to pay. Some fee you have to pay, buy clothes, you have to pay, you have to pay the rent of the house, you have to pay, taxes you have to pay, so that is the non-food expenditure, right? Now, what is that saying? So this is non, and then you say, okay, if 1,000 rupees are my total expenditure, 600 going here and 400 I'm looking for food. Okay, 400, 4,000, 4 lakhs, whatever units you want to make, right? Food. So after having the money for food for the running kitchen, you have to decide if major food group, how much money I have to spend on. You start thinking from high value quantity first. How much I require for livestock products, meat, milk, and so. Few things are missing here. Let's say livestock products, meat. That's mainly milk. How much you require for fruits to vegetables. Then you think about fruits, and then you also think about cereals. Because cereals is the major source of calories. So you divide this into a major food groups. You can make 5 groups, 6 groups, 7 groups, and then decide how much. First priority is milk. Second priority is vegetables. Your third priority is cereals. Fourth priority is food. Okay, that way you prioritize and then allocate your money for this. Then from cereals, if you are poor, then you like to put you buy rice wheat from ration shops and so. And if you are rich, you buy a better Madhya Pradesh wheat and better wheat. If you are still richer, then you like to buy basmati rice or you buy coarse rice. So that way you decide the cereal expenditure and then you allocate of that. If you are poor, you buy potato more. If you are richer, then you buy some green vegetable. If you are still richer, you buy mushroom and so many salad, pasta, and so many costly items from here. Okay? That way we decide our prioritize our expenditure. Similarly on food, if want to buy food, if we have less money, we buy banana. If we have some more money, we buy some more fruit, or we buy apple. If it's more money, we buy grapes and other. If we buy more money, then we have costly fruits, imported fruits, and so on. Right? Similarly on meat, and if someone is poor, he wants to eat meat, he like to meat which is cheapest. And so on. Now, after this is my second stage. The first stage is my food expenditure is a function of price of non-food, price of food, and income, and expenditure of total. Right? In angel function, we are saying the expenditure on rice is a function of total. Here we are saying expenditure on food is a function of total expenditure. And expenditure on food explained by non-farm, non-food and food prices. Right? Because if non-food price is high, more money will move here. Right? And that is why food, non-food, and expenditure. Then this is my first stage. Then my second stage is consumption of cereal is a function of price of cereal and expenditure on food. This is my second stage. What is my third stage? The share of rice expenditure. Share. That is Yates model in quadratic terms. Yates model, share of rice is a function of expenditure on cereal. Second equation, share of wheat expenditure is a function of cereal expenditure, and so. So this is my third stage. So once we go there, we write a model like this. Expenditure on food is a function of price of food, price of non-food, income, and fixed factors. The fixed factors may be education, maybe the education, urbanization, right, and so. Then we write a cereal expenditure, which is a function of price of cereal and expenditure on food, right? This one, and then fixed factors. In third stage, share of individual. Here we are doing disaggregated analysis in linear expenditure system and its model. Here we are doing group analysis, linear expenditure system. Here we are disaggregating cereal into rice, wheat, so many other cereals, bajra, maize. Then we have price factor of cereals. This is the price factor, and this is the expenditure on this. So first we work out this elasticity of consumption of rice with respect to expenditure on cereal. Here we work out the elasticity of cereal with respect to cereal price. Here we estimated the elasticity of food with respect to total expenditure. If you multiply these three elasticities, elasticity gone from here, multiply elasticity of here, multiply elasticity here, what you get? You get the rice elasticity with respect to income, total expenditure, which you say total expenditure. That's it, and then total expenditure is 70%. Then you say your saving is 30%. Then you adjust with that and do. if you feel that only 20% people are using the coarse grain, 80%, your theta is, the probability of using coarse grain is 20. Then you multiply that 20 also with the capacities to get the final result. Anyway, this should translate other things you understand. So here, what graphic I shown earlier, you are estimating this is my first model. Then I am estimating the second state. Then I am estimating the difference. Once I estimate the three stages, I get this model. Let's see. So in the first stage, I am writing the expenditure on food is a function of prices, income, and fixed cost. Now I say I am using quadratic, right? If this beta is equal to this, you make y, okay? In the paper it is correct. It is wrong. I try to type it y, not type. And this is y, okay? If you substitute beta here, what will happen? For beta 0, low y, right? And for this, what will come? Beta multiplied by beta 1, log y square. Not log y square, log y whole square. Right? And then you have to impose the restriction here that your model is homogeneous in income and price 0. This is the first condition of demand model. Any demand model, all regulation equation is not a demand model. Demand model must satisfy condition that it is a homogeneous in income and price 0. Yeah, that what that says, because any model is called a demand model if it satisfies three conditions. First condition is the model should be homogeneous of degree 0 in income and price. Second condition, symmetric condition, that your cross price elasticity must be equal. Rice versus wheat versus rice must be same. Then third condition is the additive condition, that your coefficient, your A coefficient of all the three equations in third stage must be equal to 0. It means we delete one equation and then we derive from the additive condition. Anyway, once we go the overcome cycle, you will understand better much more. Anyway, just keep in mind, we estimate this by OLS, by restricted or OLS. What is restriction? That your gamma I plus beta I plus 2 times delta, that is your beta multiplied by this one or this one. This coefficient and this coefficient, 2 times log y must be equal to 0. We impose this restriction, then we estimate this model. Once we estimate this model, we estimate y, this one, and place over there. And then again we estimate this model. And there also we impose this restriction of homogeneity of income and price. And then we estimate the third stage, and we impose the restrictions, that your symmetric restrictions, your cross bias elasticity are equal to different, are equal, and additive condition that coefficient of A in all the equations sum up to 1, and here also. And then what is IMR? Sum of the dependent variable is 0. If sum of the dependent variable is 0, we run the model, we get the bias To remove the bias, we compute the IMR. IMR again, I've forgotten too much, but computer on the Tobit analysis and Tobit analysis. We do the Tobit analysis, the consumption is 0, takes 1, if consumption not 0, if consumption 0, takes 0, if consumption is 1, positive, it dummy value takes. We apply the Tobit model. From Tobit model, we compute one variable IMR on the standard software. We do directly IMR, and for that we must do the Tobit and Tobit analysis, right? And then we improve this. So this improves the quality of the coefficient. While we add this, because once you have the analysis, your all dependent, everybody doing the data of 100 household. Out of 100, 20 household may not be consuming wheat, right? Or may not consuming particular fruits and so. So therefore, this is required, and then we go. So this is my additive condition. This is my homogeneity condition. This is my symmetric condition. So we apply this condition into this. I'll just try to. I put a small template which will give more clear and understand on this. Now, okay. Demand elasticities. Okay. Then another model, almost ideal normalized quadratic demand system, transcendental logarithm. These are also the models are being used for demand analysis. Although here in the your report, so we concentrated on the three-stage demand system. You may find this difficult, but just give a little exposure. I understand. In one small lecture, you can understand. But just give it some flavor. Eat this works. Now, we say requires quadratic form, 8 model, multi-stage, food characteristics. Yeah, this, and then we, last time we also compared this. Okay. Now, in the demand, we consider income, fixed factors, we consider age, we also consider occupation, education, and price of goods on and other goods. These are the factors we consider in the demand analysis. So what is the gap you can define? Either you have urbanization where dummy variable, occupation, education, and so on. Then we estimate the demand per capita consumption demand. We say we have the elasticities, income elasticity, price elasticity, and so we have the growth. The things which I explained here earlier, that if you have the different values, how to substitute and get the growth. Okay. And then we work out the consumption, multiply by population, this is the total demand. Yeah, this part I already explained on the whiteboard. Then it's a demand estimation. What is the demand? We get the from the survey data, you get the household demand only. It is the direct household demand and then the total demand will be household demand and indirect demand. What is indirect demand? Demand for seed, feed, wastage, industrial use. This is my indirect demand. I have to compute how to get the seed demand, how to get feed demand, wastage, industrial use. So, if you look the policy paper 98 of IRA, demand projection for food and supply, very detailed explanation is given how to compute these values. If you want to compute the demand for feed, you have to compute the livestock products, and then from livestock products, a conversion factor for 1 unit of livestock, how much concentrate is required, and then you compute how much concentrate is needed for livestock, and what part will go as a wheat, what part is rice and other things. Right. And to understand this more clearly, for doing the practical work, we read that policy paper 98 of IRI, right, which is there in the practitioner and is might be having some. And then home away demand. This is very important. Number of people in almost all the studies before us, what we did, home away demand is negative. We eat lot of things at the restaurant, those normally accounted by NSS. The tea maker consume lot of milk by selling tea on the street, but that is not there. If you do the demand for liquid milk, the demand will be just 40% of total production. Where the 60% gone? That is gone for this home away demand. We are making a lot of sweets. Otherwise, making a lot of sweets, consuming a lot of milk. We are using a lot of milk for making chocolate and other things. So, if you consider that, even 20% of milk in the organized activities are converted to plastic. Yesterday, we visited Ammo, they say 80% goes in liquid form and 20% converted to solid. So, you can imagine how much milk is converted to a product by halwai and other biscuit maker, tea maker, tea. So that we have to consider item by item that how much is the home away demand. And this is a food matrix we prepared and given in our paper, and then for each commodity, and those have the energy and time, they can revise those numbers. So what is the home away demand for cereals, vegetables, other so many things.
Sir, if you allow, we can have a type of 5 to 10 minutes. It's very important. Sir,
Yeah.
5 to 10 minutes. When it's good. Because we would like maybe at least half an hour. Yes, sir. So if you say, sir, 5 to 10 minutes, then. Or we can continue.
No, we may, I think it is almost over. Then we can continue the next session, we can extend further. Okay. वो चला जाएगा.
ठीक है.
फिर population projections, income growth and GDP growth. These are the factors we require. We must know what is the population growth, what is income growth, GDP growth. This is clear. So these are the things we are working to know after the elasticity. These are the factors. Okay. Then income elasticities. We are now we are going. We need the income elasticity. Okay. Then question comes: how disaggregated income elasticity I should have? Shall I compute by state? Shall I compute for the country as a whole? It is a question. Or shall I compute only region wise, north, east, west, south, center, India? And because the elasticity depends on diversification of food and food habit change from region to region, state to state. So as much as you can have this aggregation, your elasticity will be better, your projection will be better. So my suggestion is that you do your analysis at disaggregate cost base. Work out the demand for each cell and then add up. Then you can go for domicile, rural and urban separate. You do the 35 states separate, where 70 cells. You can do minimum 4 to 5 income groups, 350. to do the demand analysis for 350 cells separately, for elasticity, for everything. And then you add all together. That will be the best demand for each commodity. You are taking into account the diversification and so. But for simplicity, we say, no, I cannot do all the states. Let me do it for Gujarat. And it's in this days, क्या फर्क पड़ता है? Let's do for them together. Next.
Even sir, within the state of Gujarat, like we are doing, so within the state, region, within region again, sir.
Yeah.
So
Yeah, as you decide it,
and you are saying ultimately it is better.
always. So that your income group, we say poor, middle, so many income groups and so. That is why we say with income, as the income goes, elasticity decline, right? And this is for rural. And if you go urban, elasticity lower in urban than rural, right? So this illustration, the elasticity number that changed. And if you do separate analysis for rural, separate analysis for urban, under the separate analysis rural, you do by income group, you do by different regions, minimum regions, and so on.
So this is the area of research, sir.
Yeah, as deeply you go, you will be closer to reality. Our numbers are based on 35 states, 2 groups, 4 income. So that and rural, that is why 350 cells we build up. And then we added all of them. So we take into account the income variability, regional variability, diversification, and so on. So we have the direct demand, then we have the indirect demands, and this way, and then we also think about export, buffer stock, and so, and that we take into account about this. Then this is the demand projection. If you know just a little bit on this, I already covered, and then this already I covered how the consumption we take, we multiply with the population, and so this slide we already saw that how the demand comes and change. This I already saw. And this is important. Now, this is the one which we shown that various researchers, the error rose down 10%. Our work error was 3%. Then another study we made 98. Error was 0.4%, which is the system that we did. Rodha Kumar, the error was -3%, and Kumarika error was 4%. Now my study, the error was very good. But most of the other studies, if you go, the error is even planning commission study, the error is 20%. And Radha Krishna Ravi study, if you use the linear explanation system, 18%, and so on. Right? So there. So reasons why it is so? Why there is a wide variation across studies? As I shown, wide variation across models, because model use. Which model you are using is very important. Which data you are using, that is also important. Whether you are considering the income distribution or not, that is important. Whether you are considering the regional consumption pattern is important. Whether you are considering the dietary diversification across regions and income is very important. Right? These are the factors by which the variation, the researcher goes, the estimates go. If you take into account all these factors, you use correct model, you use right data, you use classify the data by income group, you classify the data by regional groups, you take into account the dietary diversification because of more classification, and then on the dependent, right? And common weakness of understanding. Yes, I put it. The model is specifically predicted because we do the analysis, but we don't impose critical restrictions of demand. Any model cannot be set demand model until it satisfies three conditions. They should be homogeneous, it will be zero, it will be price, symmetric and additive conditions. Now, mostly aggregate analysis ignore structure change, means urbanization, diversification, and then we ignore the population growth. Because what we say, per capita income growth. Today, we say 7% is the GDP, 2% growth of population, we say per capita income will change by 3%. Right? But we know with the time period, this population growth will decline. Earlier it was 3%, then 2, now 1.6%. After some time, it is 1.1%. It means you are underestimating the income. Because your per capita income comes GDP minus population growth. Right? So if you assume that of the baseline number in future, then you are overestimating, underestimating the income. And then most of these studies are not considered home away demand. Consumption is ignored. Many studies report whatever we conducted before that in capsule project, right? Publishing this part is used. And after we start doing this, then researchers start looking this part indirect demand and the home away consumption, and then their number is also. Now, Niti Aayog in recent reports, they take into account the numbers. They not computed their own number, they chosen my number and then it also. Right. And then I think we will take this template to this. We'll start this template. I think you not forget by that time.
So anyone have any questions?
Question to what? Yes, and then
No, it's still demand.
yes,
So that's why if you open the literature,